Welcome to the sixth and last video for the Cupertino Robotics Project CNC. And in this example, we're going to look at a block that on one face is going to have a slot, which we've done before, and on another, in the opposite face, is going to have a pillar, a little piece that will basically hold that block off the surface. So this is milling two faces, and we haven't done this before. This case, it's going to take about 20 minutes of run time. And so we want to really show our appreciation again for the Gene Haas Foundation and for the Fremont Union High School Foundation and then Tormach Corporation. Dassault Systems with Solidworks provides our CAD and CAM. And then we look at two mentors, Dave Lowe and Doug Eisant. Without their help, this would not have been possible. So the presentations we've done before, we started way back a long time ago with the simple hole, and now we're going to a slot with pillar. It turns out that these just represent about maybe 5% of the capacity of this mill, but it's enough that basically it should get you familiar with it, and then you can build on that familiarity. Remember, when I say you, I mean you and a trained adult mentor. Do not do this by yourself. You can hurt yourself. You can hurt other people in the lab, and you can do a lot of very expensive damage to the machine. So make sure that you follow these rules before you actually try running it. And then so here's a kind of a cross section of this, and this is a side view. And so we have a block, and the block is here. It's a 2x2 block, and it's a 1/2 inch thick. And then what we're going to do is we're going to put a slot on one side. We've done that before. And then we're going to put a pillar on the other side. And this is going to be a little round pillar here that will make it cute when it sits on your desk. And so we're going to use Solidworks CAD to design this, okay, which is actually fairly simple. And then we're going to use Solidworks CAM to create the CNC code. And this we'll do this by using two setups. We'll use one mill setup for the top slot. Then we'll literally flip this part over in the mill and then run it so the mill can machine the pillar part out of it. After we finish the CAM, then we'll run that G code and make sure that it does what we think it's going to do. So without further ado, let's go to SolidWorks and build this and design and CAM this part. This video, we're going to demonstrate or give an example of making a little block. It's a 2x2 block, and it's 3/4 inch thick now, because we're going to do something a little bit different. It's going to have a little slot through it like we've had before. We'll leave the hole out because I think that we kind of understand what that does. And then we're going to put it on a little pedestal, because little blocks belong on pedestals, on the other side of it. So we're going to be machining two sides of this block, and we're going to see how that works out. So first thing we have to do, of course, is we better get our sketch going. I'm going to go over here to SolidWorks, and I'm going to do a little sketch, and I'm going to, as we did before, might as well just do it as we did before. I'm going to put it on this top plane. I'm going to put a little block here, or at least a little square here. I better get some dimensions on it. So let's see, so this will be 2 inches, and this guy's going to be 2 inches. And so there, and so as we've done before, this becomes trying after a while, but it's important to go through it and just see what the steps are. So basically, we'll have our little square. Let's go through and let's make it a. I just got somebody buzzing me, but that's okay. Let's go through and extrude it, and so we're going to make it 3/4 inches. And the reason for it is we're going to be cutting on both sides, and I want to make sure we have enough stuff left in the middle. So that's there, and we look pretty good. So there's a 3/4. Let's pick this up, and on the top side of this, let's do another sketch, and let's put in a little slot on this thing. So sketch it, and we're going to do it up here, and we're going to use this as a way of getting our sketch, and it's going to be a slot all the way through. Let's see, how big should we make this slot? Oh, let's do it 1/2 inch. That looks pretty good. Okay, and we're going to make it a slot, so we have that on. We better do our features. We're going to do an extruded cut. Let's make a blind extruded cut. This wants to go all the way through. Let's just make it 1/4 inch. Okay, so we have this, and there we have our little slot on one side. Looks good. Okay, so let's now look at the back side of this. And what we're going to do is we can put a little pedestal on the back side. Okay, I'm not going to save this. Let's put a pedestal on the back side. So we do that by doing another sketch. We're going to sketch the back side of this. And I'm just going to make a little round pedestal here. And let's make it 1/2 inch in radius. And we're going to, so we got there. Now we're going to do features, and we're going to do an extruded cut. Now we're not going to cut that circle. We're not going to make a hole in it. We're going to make a pedestal out of it. So what we knew is we need to flip the side to cut. We do this, and let's make this pedestal, let's say 1/4 inch. And so let's see what that extrusion looks like. So we flip here. Looks pretty good. So we have a block. Now this face of the block we've done before, so there shouldn't be any surprises as we go through the CAM process of doing this face. The thing that's a little bit different here is we haven't done the back side of this before, so that's going to be the big difference. So I think we're okay with this. Let's do CamWorks. I better pick up the little tree for it so we figure out where we are, and so we have it here. So we're all set up. As before, let's define our machine, because if you don't define the machine, nothing happens. We already defined a mill. That's good. So let's look at our tool crib. Nothing there, but we know how to select the Cupertino Robotics 2 crib. It's right here. And we better tell it to only use those crib tools. Use crib tools only. Okay, so we got that. So that looks pretty good. Bet we don't have a post processor because it's a new part. And so this is the Tormach Path Pilot post processor. And we're going to select that. And remember, we don't really need to work on these other things. So we look like we're okay. So we have that. And so we have defined our machine. Let's do our stock manager. And let's here's the stock manager. Notice what the stock manager has done now. It's given us a block that is the full 3/4 inch high. If we look at this thing down, because we need a block that's 2 by 2 by 3/4. So the stock manager gives us this. I don't want to make it out of aluminum. I'm going to make it out of high density polyethylene. And we have it here, and I don't think we need anything else with the stock manager. So we have that. Okay, so let's do our coordinate system. Now this is something that's a little bit different. Normally the coordinate system, as we see here, is down here on the bottom, okay, and it's pointing the wrong way. X is pointing the wrong way, and Y is pointing in the wrong direction. So, but we're not going to do what we did before, which is put it up here in this corner. What we're going to do is we're going to put it in the center of this block. So let's see how we do that. So we're going to look at the bound here, and then we look at this, and it's kind of hard to see, but I think maybe this direction is going to give it to you. These 3 vertices, they're really not vertices, but this is on the backs of the underside of the block. This is on the top side of the block. This is in the center of the block. And all of these are in the center of this block, of this 2x2 block. So what I'm going to do is I'm going to put our coordinate system here. And the reason for it is when I put this in the mill, I'm going to put it with this face up first, and then mill this and have the mill the slot. Then I'm going to flip it over. And what I don't want to do is to have to reconfigure in the mill where this zero is here, the 0, 0, 0 part of the coordinate system, the origin of the coordinate system. So I'll use symmetry of this block to say when I flip it over, I don't have to change the mill. And so I think that's a big benefit. So we have it here. The problem is we have the same problem we've had before, and let's see how we're going to solve this. I'm going to go through and flip Y. So I'm going to go into Y, and then I'm going to do this with Y. I'm going to make it point in this direction. Okay. Well, it didn't quite point in that direction, but we know the problem is we just have to flip it around. So we have Y in this direction, and we have Z in this direction. The problem is X is pointing in the wrong way. So I'm going to go here, I'm going to flip X around. And so let's put X on here, and I'm going to flip X around. Whoops, there's X. Okay, now let's see what we have here. We have, let's see if I can get this thing in. We have X pointing to the right, positive X pointing to the right, excellent. We have positive Z pointing up, and then we have positive Y pointing away from us. So this is the way that we would normally set up our block. It's consistent. Let me restate that. This is consistent with the way the mill thinks the coordinate system is. Okay. The question is, we have now 0, 0. When we set up the mill, is not going to be up here in this corner, which we typically do, but it's going to be here in the center. So we're going to have to do something a little bit different, but we're going to worry about that when we get to the mill. Okay, so we have that. So I think we have our coordinate system set up. Okay, now what we're going to do is, so we've had, let's see, we've defined the machine, we have our coordinate system, we have the stock manager. Let's do our mill setup. Mill setup is here, and we're going to do 2 mill setups. The first mill setup is this top plate, top frame, plane is pointing up. Okay, so we have that. Okay, and then we're going to do another, so that's part setup 1. Now we're going to do another setup, and we're going to now have this, the bottom plane pointing up. And so we have it here, and so the bottom plane is now going to be pointing up. So now we have 2 setups on our mill. And that means, again, when we mill this thing, we're going to have to manually flip this over. The mill does not know how to flip over a piece of material as it processes it. Okay, so I think we have everything we need. Let's go through and extract the features. And what you'll see is that it identified 2 features. One feature is identified here. And if you look at it, look at the blue. The blue shows that this is one feature up here, that slot. Let's go down here, and here's the other feature, and the other feature is the pedestal. So we have these 2 features here. So far, so good. Now let's do this. Let's go through and generate a plan. And we generate a plan. Let's see, as before, we have a rough mill here, another rough mill with a smaller mill end, and then a contour that smooths everything out and makes it pretty. And then on the bottom here, we have another rough mill, and then we have a contour. And notice this is using a big mill end. It's the 1/2 inch, and before we're using the 1/4 and the 1/8 inches. So we have something that looks pretty good there. Let's generate our tool path. and we have a toolpath here. Okay, now one thing it says about this toolpath, it decided not to generate a toolpath for this rough. We just have this rough because this rough doesn't bias much, so it decided not to do that. And then the contour, of course, and then it did the same thing on the back side of it. So we have our toolpaths here. Let's step through the toolpath. Okay, and let's see what we want to do. Let's slow it down because otherwise it just goes too fast. And let's step through the toolpath. Let me bring this thing a little bit more into center and let's play it. Okay, there's the rough mill. There's the little contour, smoothing things out. And then here's that mill. Now what is going on in the bottom? The bottom is that big half-inch at the bottom is actually the thing that's milling the bottom of this thing. So let's go through and look at the bottom so we can see what's happening. I'm going to do the same thing. Okay, whoops, I got to rewind. And then I'm going to see it's doing the top. It's using the 1/8 inch mill to finish it up. Now it's getting the half-inch, and now it's doing the bottom. So this is the two passes on the bottom. So this is what we have. It looks pretty good. So I think we have that. And then let's go do a post-process on this. And we're going to name this. Okay. Let me make sure I have this in here. Yeah. I always like to put date codes here because I have many versions of these things and the date code helps. Okay, and I'm going to call this a slot, if I can spell slot, with pillar. Okay, so I have that. Okay, and then I'm going to run through and generate the G code. Okay, so let's take a look at the G code. And we'll pick it up here. Okay, here's what the G code looks like. Okay, we're using a total of 4 tools, or 3 tools. We have a 1/4 inch, we have the 1/8 inch, and we have the half-inch. So that's a lot of stuff. We're going to start off with the 1/4 inch, okay, to mill out to do the rough mill on the on the slot. So this is the top of it that we're doing. So we're doing the slot here, okay, and then we're doing a contour mill. Notice we missed the other rough mill, and so here's your contour mill starting. That just smooths it out, makes it pretty, okay. And so we're going to use now a 1/8 inch, which is right down here, and then we do a couple of steps here. And that just smooths out the edges, okay? Now we pick up another rough mill here, and now this is on the bottom, okay? Now, notice what happens here, and I can tell what's going on here because we have a G0 here. So what happens is after it does the contour of the top, the spindle is going to come up all the way up to the up position, and I will know then that it's time to flip this thing over. So this, and also put the half-inch in. So I have those as my kind of, I'll wait to run this program until I flip it over. Okay, so I'll run it here. This is the rough mill with the 1/2 inch, and then on the bottom now, this is cutting the pedestal, and this is the contour mill. And notice what it's still doing. It didn't pick up another tool, so it's going to do the contour, the smoothing out, using the 1/2 inch, okay, which is typical when you're cutting these big open faces. So that looks like the program that we have. So I believe this is an attempt. It's not an attempt, it's an absolute foolproof way of showing how this thing actually works when we're trying to do 2 sides. Now, if you're trying to do 3 sides, 4 sides, what you do, you just have different setups. So we would have setup for one side, setup for the second side, set up for the third, fourth, etc., and move these things around. Okay, so that's the end of this video, and we'll take it over to the machine and see if it works. The polyethylene block is securely affixed into the vise, and now we're getting ready to cut the slot. The first thing we'll need to do is load a T2, which is that 1/4 inch end mill. We just loaded it, and then we will cut the slot. We've seen the slot before, so I'll just speed it up when we go through it. It's normal speed. Okay, now we're going. So now it's stopped for the tool T1 for the contour mill. Now it's stopped for us to flip it over. So I'm going to loosen up the vise first, the split vise. Loosen those and it opens up the vise. Now notice the pin back there. I'm slow motion. There's a pin sitting there, and that will, I'll use that to find the same location on x equals 0. So I put the polyethylene in the vise, and I slide it in the vise and press it up against that pin. Now we're going to tighten the vise, and the important thing here is tighten the vise. We have to tighten it so that the vise is not twisted, otherwise the material can come out. So it looks like we're down. I want to see if I can pull it out. Still looks good. I'll do a little nudge tight, and then we'll get ready to mill the pillar, and we use a T4, which is that big 1/2 inch mill. And we can do that because we're just taking a lot of material out off the bottom, so we get the little cylinder that forms the pillar. So we speed it up. And by the way, many of the mills, this is actually how fast they'll run. But again, we run ours slow, and so we don't put a lot of pressure on things. So we just took most of the material out. Now we clean it up. We now do a little contour, and we're done. Take a look at a previous try of the slot with pillar part. I'm just flipping the part over. We've already done this slot. And now I'm tidying up the split vise, and I'm not being very careful. You see, I just tightened up the screw that's furthest away from us, and I didn't tighten the screw that's closest to us. So what's happened, there's a little tilt in that vise, and so we put the big 1/2 inch tool in, the end mill in, and then we're going to mill it. And so it's just like before. It's going to cut the edges around. I'm just going to run this at low speed because, or standard speed, because this is going to happen. We're not going to complete the part. And what's going to happen here is we continue. And notice the big chips that are being cut out of there, which means this mill is putting a significant amount of strain on it. Now it's coming around. Now watch it closely and we'll see what happens. Bang. Let's look at slow motion. By the way, the mill doesn't know that this thing left, so it's still happily working. It's slow motion. It's coming up there. You can see it pick up, so it's not moving, it's picking it up out of the vise. And then there it is, still milling, and then it flips it out. So it's important to keep your stuff clamped down.